So this is the first video for Chapter 9, and it's just an introduction to this idea of sampling distributions. The first section of the first part of the first section of the chapter is really just going to be giving you some definitions and some basic concepts that we'll be using, not just for the rest of this chapter, but really for the rest of this course. So the first couple of things that you need to be familiar with is the difference between a parameter and a statistic. A parameter is a value that we are measuring from the population. And remember that a population involves all of the individuals that we are interested in learning something about. So we could be considering the population of all of the adults in the U.S. We might want to make some inference about that population. So a parameter is going to represent the actual value for that entire population. A parameter is not actually something that you can calculate because your population is most likely so large. So because you can't calculate your parameter, what we do in statistics is we use an estimation, and that is exactly what we call a statistic. And that statistic comes from the sample that you are taking. So we've talked about this idea already, but what we're doing here is we are pulling data from some sample, and we are using that sample to be representative of our entire population, which means we use this value, the statistic that we get from our sample, and we use that as an estimate for the value of the parameter. There's some notation that's going to be important to be familiar with, and again, this is something that you're going to see throughout the rest of the course. Whenever we're talking about a population proportion, we're going to use just the letter P. And I know P showed up in Chapter 8 when we were talking about the probability of success, but this is a different P that we're talking about. This is a different setting. When we're talking about the proportion of a sample, we will use the notation P hat. And remember that hat notation just means that it's an estimate, which makes sense because if we're talking about a sample proportion, that means that we have the sample is the estimate for the population. When we're talking about a mean, if we're trying to measure a mean for a population, that's when we are going to use the notation mu, which you've already seen before, to measure mean. And then when we are talking about a sample mean, that's when we're going to use the notation x bar. So x bar represents the actual sample that you're collecting for the mean, and then mu represents the population's mean. So you do need to keep these four different notations in mind. So the last thing we need to talk about in this video is this idea of a sampling distribution. So a sampling distribution simply tells you the distribution of outcomes for various sampling events. So here's the definition of a sampling distribution that's given by your book. It says the sampling distribution of a statistic is the distribution of values taken by the statistic in all possible samples of the same size from the same population. So this just means that for every sample that you might take from your population, that value is going to show up somewhere on your distribution. And what this also means is that each time you take a sample from your population, you're probably not going to get the same results. Your results are going to vary slightly from sample to sample, and that's okay. And the reason that's okay is because when you take a look at your sampling distribution, you're probably going to see something that will end up looking a bit like a normal curve. If your actual population mean, maybe you're measuring, you want to estimate the mean income for adult Americans or something like that. If your actual population mean lies here in the middle, then as you take your samples, you're going to end up getting more samples here close to the mean and very few of your samples are going to show up here on the outskirts. So this is really a similar idea to others that we've talked about earlier this year.